We're going to talk about the teaching, assessment and retrofitting of structures. More specifically, start off with a little bit about who we are, then look at the key skills required for assessing, retrofitting existing structures and how those skills differ from the skills required for designing new structures, then how the skills can be developed and assessed. So who are we? So Elizabeth's kindly introduced us, so myself and Jon Carr. So I think the main thing to emphasize here is that we very much come from an industry background rather than a traditional research background, and that's informed how we've developed our approach to teaching reuse of existing structures. So a few examples of projects, reuse projects we've worked on whilst in industry. Going to say a little bit about our module we've developed at Sheffield, but we've presented about this a number of occasions on the past, not least at this conference a couple of years ago. That's been captured in papers, so I'd refer you to those if you want to find out more about the details of what we've done. So in terms of key skills required for assessing and retrofitting existing structures, I think the first thing to say is that the underlying principles are very much the same as when designing new structures, but we do think there's a different mindset involved. So one way to think about this is that in some ways structural engineering is quite conceptually quite easy. We've got a bunch of loads applied to a structure, might be vertical, might be horizontal, also above ground level. And all we need to do as structural engineers, it's a little bit tricky in this in practice, but is find a way to get those loads down to ground level in a controlled manner. And that means finding a path for each load to get down to ground. So if we're doing that on a new building, then we have the luxury of being able to decide what those load paths are, working with the rest of the design team. We might choose to keep those quite simple. We might need to make them more complex, but key thing is that it's in our gift to determine them, similarly to determine what materials to use. When it comes to working with existing structures, someone else has already decided what the load paths are and decided what the structural materials are. So the first thing we need to do is understand the thinking of the original designer. Why did they choose those particular load paths? What are the load paths? Why did they choose those particular materials? That's the first step. But if the building's been in existence for some time, then people tend to do things to buildings, they change things, and those changes may well have affected the existing load paths or the load paths as they were envisaged by the original designer. So we have to understand that. Similarly, the materials may have changed, deteriorated over time, so we have to understand the materials in their current condition. And doing that may take quite a lot of detective work in some cases. So it's only once we've done that, understood those factors, that we can start to think about any new interventions with any level of confidence. Even then, that's not the end of the story. We can't wish our new interventions into place. So we have to understand how they're going to be constructed, what effect that will have on the existing load paths, and making sure we're maintaining a viable load path for every single load all the way through that construction period. And that could sometimes involve some quite significant temporary works. So that's the mindset. I'm going to hand over to Jon now to talk more about the skills that need to be developed.
Thank you, Richard. So not surprisingly, there are many skills are required by structural engineers when working with existing structures. And we're going to talk about some of those in a minute. We've basically categorized them into technical and non-technical skills. Probably not an exhaustive list. I'm sure you might be able to think of a few others that we've not picked up, but we felt these are the sort of key skills. And interestingly, quite a few of those skills are also required when working on new structures. So whilst teaching reuse modules and projects, it's obviously important to focus on those skills that are particularly relevant to existing structures, but at the same time bearing in mind the fact that students will be gaining a lot of reinforcing of skills that they will require to design new structures. So that's a sort of win-win situation, if you like. It's also really important to bear in mind that given the sort of limited time that we probably have to to spend on reuse modules in undergraduate programs, a lot of the skills will be developed post-graduation, i.e. on the job. Thank you, Richard. Okay, so looking at some of those key technical skills. So the first one of those is an ability to apply first principles appropriately, which comes as a bit of a shock to some of our students. They think everything you need is in the Eurocodes. We tell them that's actually not the case, and you really need to go back to first principles in many cases when you're designing existing structures or evaluating existing structures. It's also really important to have an understanding of historic design codes, if they indeed existed, or any other relevant design guidance available at the time that the building or structure was built. It's also really important to have an awareness and understanding of historic construction materials, structural forms. So, for example, jack arches with rubble-filled concrete, for example, something you don't see now, but is quite commonly used in older structures. Historic construction methods and materials again. So it's also really important to think about upper and lower bound solutions. So, for example, if you're trying to assess the capacity of an existing masonry wall, so the strength of masonry can vary hugely. So it's always helpful using published sort of data to get a feel of what the minimum capacity of that wall could be, and then the maximum capacity, and then compare that to what the applied loads are. And that might then give you an idea of what, if anything, you need to do. And it may be the case that actually, even considering the worst case scenario, you're absolutely fine. As Richard's already discussed, load paths are really important. Trying to understand the existing load paths, the load paths in the final condition, but also how you get from the existing to the proposed arrangement. And there may well be a range of different load paths as we go through that construction process. So it's important to understand them, as it is temporary works that are going to be required, again, to get you from the existing situation to the final structure. Defects are clearly really important, and materials, condition of materials when you're assessing existing structures. And similarly, testing and inspection methods, and if necessary, remedial and strengthening works. It's again important to have some experience and knowledge and awareness of those. And last but not least, it's really important, as Yasmin has already alluded, to take a holistic approach. It's not just about the structure, there are lots of other considerations. So we need to be talking to the rest of the design team, to the conservation people, the architects, the building services engineers, the fire engineers, the acousticians. So we're just one part of a much bigger team. Thank you, Richard. And then moving on to non-technical skills. It's pretty unlikely that somebody is going to give you all the information you need at the start of a project when you're looking into an existing structure. There isn't a fairy who comes and does this for you, so you're going to have to go out and find it for yourself. So you're going to have to have an inquiry mind and be resourceful, have good research skills, and being able to mine information from a variety of different sources. This information is invariably going to take a while to appear, so you're going to have to be pretty resilient, pretty patient in that process. And when you do get the information, it's highly unlikely it's going to be complete. There will be gaps in there, so you need to think about how you're going to address that, and that goes back to testing and inspections and things. And the information that you do get is unlikely to be 100% consistent. There are likely to be some inconsistencies in there, so it's important to be able to critically assess that information to come up with some conclusions and some proposals for trying to reduce the risks and get more accurate information. Now, when I was working in industry as a fairly junior engineer, I learnt a lot from colleagues on the job, more experienced colleagues. So not everything we need to know about existing structures is going to be written down in books. There clearly are a lot of useful resources out there, but it's really important to learn from your peers, and this gets us into the idea of lifelong learning. Every day is a school day, as they say. Perhaps somewhat counterintuitively, creativity is just as important on existing buildings or structures as it is on new structures. So, for example, if you're trying to look at options for removing a series of load-bearing walls in an existing structure, or adding a vertical extension to the top of an existing building, for example, there are clearly lots of different ways you could do that, so you need to be creative and look at the options and the pros and cons of each option. When you're working on existing buildings or structures, invariably on site things will appear, as we open up the structure, that we haven't expected or anticipated, that change our solution, so we need to be able to deal with that. So we need to have a flexible and sort of fairly agile approach and be open to alternatives. Not surprisingly, communication is really important, and particularly so when you're working with planners and conservation officers, for example, and other members of the design team. It's important to have good negotiation and influencing skills. Thank you, Richard. So they're the key skills that we feel are important when designing existing structures. So how do they differ from designing new structures? So we started off looking at a fairly simple conceptual model of a Venn diagram. So on the left-hand side, the skills required for new structures, and on the right, the skills required for existing structures. And in the middle, there's an overlap, quite a significant overlap, as we'll see in a minute, of the skills required for both. However, we felt this is a bit too simplistic, so we then developed a more sophisticated Venn diagram with splitting up the new structures into non-complex and complex structures. And what we'll see in a minute, there's actually more overlap between the skills required for existing structures with the skills required for complex new structures. There's still clearly some overlap with non-complex new structures, but not as much as required for complex structures. Thank you, Richard. So this is what we did. We just did a fairly sort of thumb in the air estimation of what we felt the key skills were for those three different sort of types of structures. So non-complex new structures, complex new structures, and existing structures. And you might disagree with the number of ticks or whatever that we've put here, but I think as a general principle, it illustrates the point that there's actually quite a lot of overlap between existing structures and complex new structures. Some overlap with non-complex new structures, but clearly the sort of level of competence you need for existing structures and complex new structures is greater than for non-complex. And of course, there are some areas of knowledge and technical skills that are unique to existing structures, for example, historic design guides and rules, knowledge of historic construction materials, structural forms, and construction methods are clearly unique. And those are things that certainly you would need to focus on in a reuse module. Thank you, Richard. Another example of something that's particularly relevant to existing structures, so defects, testing methods, remedial strengthening works. So again, they should definitely be covered in any reuse module, but they are also relevant to an extent when you're looking at new structures. So again, it does reinforce those skills required for new structures. So again, it's a win-win. Thank you. Moving then onto non-technical skills. It's a similar sort of situation. So we can see there are some non-technical skills that are perhaps not unique to existing structures, but certainly very much required more for existing structures than for new structures. So for example, dealing with incomplete information and inconsistent information is much more of an issue. And then a lot of the other skills, non-technical skills required for existing structures, there's quite a lot of overlap, particularly for complex new structures and to a lesser extent for non-complex new structures. Thank you, Richard. So we've talked a lot about the skills that students and indeed graduate engineers will require, but I think it's also worth briefly talking about the skills required for teaching staff. So teaching staff should ideally already have the non-technical skills that we just talked about, but they may not have all of the technical skills, particularly if they haven't had industry experience or not extensive industry experience. So therefore, it is helpful if you do have staff with industry experience for them to be involved in your reuse modules. There's also a sort of different mindset from a teaching point of view as well. For example, being able to and comfortable to tell students actually there isn't a definitive answer, there are lots of potential solutions, and actually there may be they may get different answers from different people, and that's certainly something that we came across when we were teaching. So if there were 3 or 4 tutors in a tutorial, students would ask the same question to several tutors and get slightly different answers each time. But again, that's that will happen in industry, and I think that's something why students need to have good critical assessment skills. Thank you, Richard. So even if you do have staff who have good industry experience, I think it's still really important and really helpful to bring in people from industry, practicing engineers or architects or whatever on these reuse modules. And there's a number of really important things that they can do. They can help to set the brief, to deliver lectures and provide real-world case studies of projects that they're working on or have worked on, arranging site visits and assisting with tutorials and project reviews. Thank you, Richard. And of course, it's always going to be helpful to map the skills from your reuse modules, to think about how they align with other modules and the overall accreditation criteria. Think about whether there's any gaps that have been left or any significant overlaps. So clearly you're going to be thinking about AHEP4, JBM, Engineering Council UK Spec, which are all essentially trying to do the same thing. But it's also probably useful to think about the IStructE core objectives to help students to start thinking about their journey to becoming chartered engineers. Thank you, Richard. So yeah, I'm going to hand back to Richard now.
Okay, thank you, John. So going to look briefly at ways these skills could be developed. So I'll talk about our model at the University of Sheffield. Yasmin's already talked about the model at UCL and briefly touch on proposed model at the University of Strathclyde. So introduced to reuse of existing structures, University of Sheffield in 2022-23 academic year. It's a final year optional module for our MEng students, runs throughout the autumn semester, worth 15 credits. So core content was delivered by myself and John for the first few years, with John stepping back to concentrate on his own practice. Johnny Hurst, who's hopefully somewhere in the audience, has taken over delivering that part of it. We recognise we can't cover everything, so we have guest lectures by academic experts and practitioners. That's partly to cover other aspects of civil and structural engineering, but also to cover more holistic aspects like architectural and building services considerations. There's support for practicing engineers in the tutorials, and we think it's very important that the course includes site visits so students can see what we're talking about in practice. In terms of assessment, we don't think it's appropriate to assess a design module by exams, so it's assessed by coursework, and to allow the students to tackle more complex problems and develop some of the skills John touched on. It's a group project. Scenarios, they need to put a vertical extension onto one of 2 existing buildings, and they produce a report showing their concept design for the extension, the construction sequence, but also their evaluation and justification of the existing building, both in its existing state and with the interventions. Let's look at embodied carbon calculations. Good news is it's proved very popular. Big proportion of our students have chosen to take the module, and quality of the work that's been submitted has been really good. So that suggests there's a really good level of engagement. Overall, the student feedback's been very positive. A few things slightly less positive is for the first few years we had 3-hour lecture slots, which students didn't like, and to be fair, neither did we. So we've now adopted shorter slots. It seems to be working better. The other 2 is perhaps a bit of tension between students. The first case being very comfortable or more comfortable with calculations, so wanting to see those introduced earlier, whereas we think it's very important that students develop the holistic understanding of the building that Yasmin referred to before they dive into the numbers, and then getting the balance right between guest lectures that are very much targeted on helping the students with the assessment for module, as opposed to developing a more rounded understanding of the issues they might face when we go out into practice. Strathclyde model, so this came out of a fourth-year dissertation by student Cara Brody, supervised by Viola Valentine, who again I think is in the audience. And they were looking at how to best incorporate refurbishment principles into the curriculum at Strathclyde. So that was looking at identifying the importance and benefits of refurbishment, looking at case studies from other universities. So that's how we came to be involved, and then proposing guidance. And interestingly, the outcome of Cara's work was a very different model to one that we've adopted at Sheffield and Yasmin at UCL, where it's taught as a final year module. That was looking very much at embedding reuse principles into curriculum from the very start of the course. So emphasising there's different ways of achieving this. So in conclusion, we think it's really important that we equip our students with confidence and competence to tackle reuse of existing structures. We very much encourage you to do the same. The reasons for that is, as part of our response to the climate emergency, then building less, reusing structures is becoming increasingly important. I'm sure Andy will touch on that more. And a shot of that is a lot more of structural engineers' work in the future is going to be on reusing the existing structures. A lot of the skills, as we've seen, are similar to those that you need for designing new structures, but it does need a different mindset. I think that applies to both the students and the staff. Different approaches to integrating reuse into curriculum. So it's deciding what's going to work best within the context of your course, and strongly encourage you to engage with industry on reuse modules. So whether that's through alumni, an industrial advisory board, or indeed the institution.